Hey guys, I just want to talk a little bit about this lab. I want you guys to write up the floating leaf disc assay. So on Wednesday, we collected data using a sodium bicarbonate solution. You have to read the background information here. You have to do it, okay? And just read all of the information. And this part of the thing tells you about the procedure of using ET50. Okay, why we use it and how to calculate it. It's pretty straightforward. So the other day we collected data. You collected data on the 0.2% sodium bicarbonate solution, and you put the number of discs at every minute in which they were floating. And then you found at some point where there was 50% of the discs were floating. So let's just say on this one at 10 minutes. Okay, so I said, I'm just going to go ahead and put some data in. Let's say we had like 0, 0, 2, oops, not 20, 2, 2, 2, 3, 4, 4. Then we're back over here, 4, and then 5, and then say it goes 6, 6, 8, 8, 10, 10. So if this was my data from the other day, at what time point do I have 50% of my discs floating? Well, we can see it would be at 10 minutes. So my ET50 for the sodium 0.2% sodium bicarbonate solution would be 10 minutes right there. Okay, my 1 over ET, that would just be 1 over 10 or 0.1. Right? Because 1 divided by 10 is equal to 0.1. That's what that would be. So over here, I would change that to 10, and this down here would be 0.1. And that would be my data for that right there. Today, we calculated and recorded data for just using distilled water. Well, some people didn't get any floatage at all after 16 minutes, and some people did. Could be a lot of reasons for that. The leaves were taken out of the water. I'm not sure exactly when that happened, but somehow that did happen. So they might have been dried out a little bit, and some people's might have been fine. So that's a potential error that did happen. But anyways, you were supposed to calculate ET50 for your table group. And then you were supposed to go ahead and add it to this graph. And we did it up here let's look at the bottom one. That's the sodium bicarbonate. So group 2, they calculated their ET50. And we see for table 1, it was 0.44. Table 2 was 0.3. Table 3 was 0.4. Same for table 4. Table 5, it was 0.18. And table 6 was 0.2. The average was 0.32, standard deviation was 11, standard error of the mean was 0.05. Now, what I could do up here, remember, I want you guys to create a graph with error bars with plus or minus 2 standard errors of the mean. So for this data set, plus or minus 2 standard errors of the mean would be 0.32, that's the mean, plus 0.1.
Leftover dressing and mac and cheese in the main office kitchen, and some Ziploc bags if you want to come get some.
Sorry about the interruption there, guys. Leftover turkey dinner at school. So 2 times this would be 0.1. So this would be the error bar on this one would go up to 0.42, and it would be 0.1 minus 0.32 minus 0.1. It would go down to 2.2. Okay, this one up here would be 0.06. We double that. That would be 0.12. So our error bars are going to go up to, our average was only 0.1 because we had some 0 up there. And so this is going to go up to 0.22 and down to basically 0, just below 0, a negative number. That would be our error bars that we could put on there. So once again, you would have to calculate, make a graph of your data. If you want to use Google Sheets, this is the way you would have to sort of set it up. You would have to put it distilled water and put the average there. Baking soda, put the average there. I can now um, choose all that. I can go to insert graph. Now I'm going to get a graph like this, but now I need to go ahead and add stuff. I have to give an x-axis, a y-axis. You might wonder, what is y-axis? The y-axis is basically floats per minute, okay, because we recorded our data in minutes, so my y-axis data would be floats per minute. The reason why we do the ET 1 over ET50 is, as you can now see, distilled water has a very low floats per minute, whereas baking soda has a much higher floats per minute. And if I did it the other way around, it would look a little funny. And we can talk about that a little bit later. So you should include a graph that looks similar to that. And you can add error bars. Remember how we add the error bars. We have to go to the series. We have to scroll down till we see error bars. We have to change it to constant. Okay, and then we have to change our error bars. I think it was 0.1 was our error bar, and there's my error bars on that particular graph right there. I can change the color of the error bars. Okay, I can change the color of the bar. I can do all sorts of stuff. There's my line. I can I can make the line thicker. All right, if I wanted to, I could make it. Let's see, 4-point. I can do that. I'm not sure if I can change the color of the line. Line opacity. Yes, line. Oh, yeah, line color. I could make it blue if I wanted to. Oh, excuse me, that's going to that line. It's a little bit different. I thought it was doing the error bars. It's not. I don't know. Maybe you can. I don't think you can. But anyways, you can mess around with the graphs quite a bit. And just make sure you have all your labels on there and all that stuff. All right. Hope that helps. And remember, you have to design an experiment now. You do have to design an experiment that looks at a different variable. Okay, so look at your notes. We can vary the wavelength of light. We could vary potentially the sodium bicarbonate percentages. We could vary the plant species that we're using. Maybe we could vary the type of light bulb that we're using. We use color changing LED bulbs in this particular experiment. You could do a little research on some of those and come up with a different type of light bulb. Temperature could potentially be manipulated. I've had students do that before. So those are all different things that could be done. Alrighty, we shall see you next Monday, and you will submit your experiment by class time next Monday. Thank you.